In this video, we will tell you a story of Pioneer Venus's Large Probe Neutral Mass Spectrometer data and its incredible 40-plus year journey at the NSSDCA. It's a scientifically interesting set of data that went from digital to analog and back again, and it helps highlight some of the NSSDCA's important roles in preserving NASA's legacy data. Venus. Earth's twin in size, but a world of unimaginable heat, crushing pressure, and acid-filled skies. In 1978, NASA launched two spacecraft built by the Hughes Aircraft Company in El Segundo, California, with the intent to study the atmosphere of Venus. The mission had two parts, the Pioneer Venus Orbiter and the Multiprobe, four small landers destined for a fiery plunge into Venus's deadly atmosphere. The orbiter mapped the surface with radar and revealed a turbulent volcanic world shrouded in mystery. Then the probes were released into the atmosphere. They sent back vital data as they fell through toxic clouds. One of the Multiprobe's crown jewels was the LMNS, the Large Probe Neutral Mass Spectrometer. As the large probe plunged through Venus's thick clouds, LMNS sniffed out the chemistry of the atmosphere, measuring the composition of gases like carbon dioxide, nitrogen, water vapor, and sulfur compounds. It helped unlock the secrets of Venus's toxic air and gave us the clearest view yet of the planet's runaway greenhouse effect. The LNMS returns data in digital format, the first step of the data's journey. After the heat shield jettisoned at around 67 kilometers, LNMS took roughly 28 minutes of data as the large probe descended through approximately 64 kilometers to the surface of Venus. During its descent, LNMS's parachute unfurled around 45 kilometers. The data was transmitted to the orbiting Venus Pioneer and then sent on to Earth. The principal investigator, or PI, of LMNS then digitally processes the data. Although initially digitally processed, the data delivered to the NSSDCA was in analog form as a paper printout. In 1983, NSSDCA received a package of 29 pages of spectral data in tabular form, shown here in yellow, a cover letter, and a preprint of the paper Pioneer Venus Sounder Probe Neutral Gas Mass Spectrometer by Hoffman et al. In 1980. The right panel in green is the NSSDCA's transmittal slip that indicates the LMNS data were received on 8/8/83 by Winifred Cameron, who also was involved in the Gemini and Apollo programs. She directed staff to microfilm the data and the printout. The NSSDCA archived the microfilm as an analog collection known as PSPA 00037. Between 1983 and 2013, NSSDCA received several requests for these data. In 2020, during the COVID shutdown, NSSDCA received a request for PSPA 00037 from Rakesh Mogul and Sanjay Lemay when there was speculation of phosphine in the atmosphere of Venus. For this request, the NSSDCA scanned the 29 frames of LMNS data to the PSPA 00037 into TIFF images. The NSSDCA archived the scans as a new digitized NSSDCA collection, PSPA 00649, then sent the scans to Mogul and Lemay. Mogul later used those data for a talk he gave at Goddard Space Flight Center. In 2024, the analog LMNS data became digital again. Young-In Wan and Steph McLaughlin used OCR, or optical character recognition, to read in the 29 TIFF images from PSPA 00649 into 29 text files, scrubbed the results of a few transcript errors, and concatenated the 29 text files into one spreadsheet. Working closely with Dave Williams at the NSSDCA, summer intern Inez Bacocha was granted access to the shared files so she could begin analyzing the data. At this point, the LMNS data included the data frame number and altitude, but not the timestamp. Inez's goal was to analyze and merge interpolated time, pressure, temperature, and density data from the large probe's atmospheric structure, or LAS, experiment into the LNMS data and archive the results in the NASA Planetary Data System, or PDS. The LAS data were taken at a faster cadence than the LNMS data and therefore contains more data points. The LAS data in Table 3A above are summary data at 1 kilometer intervals. Table 9 shows large probe entry events. The right panel diagrams the LNMS's mass analyzer and electronic units. LAS data live at NSSDCA on tape in an ASCII format as part of the Pioneer Venus Special Events, or PVSED, collection, PSPA 00034. In 2024, the NSSDCA extracted the PVSED LCD data from tape, massaged it into PDS-4 compliant form, produced a data bundle, and archived it in PDS as the PV Special Events Bundle. INES performed two separate interpolations of the LAS data, one using altitude, the other using frame number. They merged both sets of interpolations using the LNMS, spectra, and output the combined LNMS plus LAS digital data as a spreadsheet. The digital spreadsheet shown above continues to the right. The entire data file contains 51 rows, or readings, of 232 columns of spectral data ranging from 1 to 208 atomic mass units. This slide is a snapshot of only the upper left portion of the data file. The yellow shaded columns are LMNS data, blue columns are the merged altitude interpolated LAS data, green columns are the merged frame number interpolated LAS data. For PDS, we added a column after Alt, column 3, for electron energy, electron volts, selected for this scan, 70, 30, or 22 electron volts. It was missing in the final file from INES, but is shown in this slide. The normal electron energy was 70 electron volts, but 3 times during the descent, the ionization energy was cycled on successive scans to 30 and 22 electron volts. These lower energies are marked with an asterisk after the data count values in the original data. We converted the LMNS and LAS spreadsheet that INES produced into a PDS-compliant CSV format and produced a PDS-4 bundle, which included a user guide. Bundles resulting from this project include Pioneer Venus multiprobe data, differential long baseline interferometer data, Venera 216 and Vega 1-2 energetic particles data, Mariner 5 magnetometer high-res data, Pioneer Venus orbiter radio occultation atmospherics turbulence data. The resulting bundle DOIs are listed in the description of this video. The NSSDCA and PDS have an ongoing project to restore legacy Venus data held at the NSSDCA and archived in PDS for use by future researchers, thus fulfilling the PDS goal of preserving NASA mission data and making it freely available for everyone.